at the request of the quality management team, who's helping make sure that this class is meeting your learning needs, I have put together this review of the various things that we have covered up through the second exam. We have talked about z-tests, t-tests, and ANOVAs, and this chart shows one way of figuring out which test that you should be using. The first thing I usually ask myself is, how many things am I comparing? 2 things or more than 2 things? If it's just 2, I then ask myself, have I been given information about a population? Does somewhere in the question it say the norm for people in general is this, or the mean for people in general is that? If so, I then ask myself, have I been given a population standard deviation, or is that population information only a mean? If I also have standard deviation for that population, then I'll do a z-test. If not, I do a single sample t. The real trick here to be careful of when you're making this decision is whether the standard deviation that's been given belongs to the population. You very well may be given a standard deviation for the sample. That has nothing to do with the decision that you make. If you don't have any population information at all, you just have 2 groups to compare, the next thing I ask myself is, was there a repeated measure used? Did they do something before and after, a pre-test, post-test kind of thing? Or did they ask 2 different questions of the same group of people, and I want to look for a difference between responses to those 2 questions? If the answer to those things is yes, then I've got a dependent samples t-test, also called a paired samples t. And if not, if I've just got 2 groups of people that have nothing to do with each other, then I've got an independent samples t-test. If you've got more than 2 groups, then you're going to be doing some sort of ANOVA. And the next thing to figure out is, are all your groups organized by 1 variable or more than 1 variable? So I might have 4 groups, freshmen, sophomores, juniors, seniors. Those are all defined by just 1 variable, year in college. If I've got men, women, freshmen, sophomores, then those 4 groups are defined by 2 variables, gender and year in college. The next question I ask myself, if I've got only 1 variable, is, do I have something that's got a repeated measure? If the answer is no, then I can do a one-way ANOVA, and that's the only one you actually know how to complete. Well, you do know how to do a factorial ANOVA. For a one-way ANOVA, you only know how to do a between subjects one-way ANOVA. You have not actually learned how to do a one-way repeated measures ANOVA, although the process is very similar. If you've got more than 2 variables, then you're doing a factorial ANOVA. If you've got 2 variables, you're doing a 2-way ANOVA. If you have 3 independent variables, you have a 3-way ANOVA. I will never actually give you a 3-way ANOVA. This is that same information displayed in a different format. So sometimes when I look at studies, I see that I have 1 continuous variable, and I then ask myself, what am I comparing this to? Am I looking at a population with a known mean and standard deviation, in which case it's a z-test? Or have I just been given a population mean, that people in general have a mean of this? Or if powers equal, they should have a score of 4, or whatever it might be. And if I've got a mean without a standard deviation for the population, I use a single sample t-test. The other 5 tests are shown in the table below. So 2 groups that are unrelated is an independent samples t, 2 groups that are where the repeated measures is a dependent samples t, 3 or more groups that are unrelated is a one-way ANOVA, 3 or more groups with a repeated measure is a repeated measures one-way ANOVA, which I will never make you do. 2 independent variables, now you still have a dependent variable in there, but if you've got 2 variables that identify groups, then you're going to do a 2-way ANOVA, which is a factorial ANOVA. That, I'm not sure if you've completely noticed or not, is always done with unrelated groups. Now it is possible to do a 2-way repeated measures ANOVA. I will never give you that. There's also something called a split plot factorial design, where you've got some variables, some independent variables that are unrelated and some that are repeated, and all of that just gets too complicated. So whenever I give you a 2-way ANOVA, it will be a 2-way ANOVA where the 2 independent variables are describing unrelated groups. Okay, if you're comparing two groups, what you do first is look at the p-value, decide if it's less than 0.05. If it is, your result is statistically significant, and you go on and look at the descriptive statistics to reach a conclusion. If the answer is no, if your probability, your sig value, is not less than 0.05, then you decide it's not statistically significant, and you conclude that there's no difference. Notice that, although you might be asked to report the descriptive statistics, you don't describe anything about the descriptive statistics. So you should never say, this group is higher than that group, but it's not statistically significant. Instead, say there's no difference between the groups. Okay, so if you have a single sample t-test, that's one way you have two groups. You first look at the p-value. In this case, there's no effect. That number is not less than 0.05. If it were less than 0.05, I would then look at the descriptive statistics, and to make sense of that, you need to compare the mean to the test value. A dependent samples t works pretty much the same way. First, look at the p-value associated with the t here. Again, I've managed to pick one that is not statistically significant. If it were statistically significant, I would then look at the means. As a brief aside, if you're looking at real SPSS output, there is another table that is printed in between these two that also has a p-value. Ignore that one. That's not telling you anything you want to know. You only need to look for the p-value associated with t, the one that's circled here.